interest, simple interest, and then we talked about in the immediate last class, we were talking about how do we mix up this interest rates? How do we mix up these ideas? As in, that is, given the final maturity amount and in rate of interest and other things, how do we find the principal and such things of that sort? Now, we are going to change the route a bit. Because yesterday I opened my bank account and then I found that there were two other things. One was called recurring deposit and the other is called SBI Dream. They said, you decide how much you want at the end of this month, end of this much time. And depending on the amount you say, we'll tell you how much you have to pay monthly and they'll compound the interest and everything and tell in these many months, if you say I'm saving up for my next year birthday, then in 1 year, I need this much amount for this purpose. All right. And then they'll say you pay this much amount of money every month. Then we'll assure that in 1 year, we'll give you a sum of, or in 1 or 2 years, we'll give you a sum of this amount. Interesting, right? How do they do it? That's very curious. It's interest, but at the same time, instead of principal amount being fixed, we are going to have recurring investments into it. RD is also like that. You're going to have recurring deposit into what you're investing. How do you calculate in that case? How do you calculate this change over time or addition of investment over time? That's what we are going to do. Now, I'm going to give you almost 5 minutes and a few puzzles. First puzzle is this. All right. So give a shot and I'll give you, let's say 3 minutes. So sharp at 2, we'll do something called a chat bomb. What you have to do is solve the puzzle. In 2 minutes, I'll tell you when you can send. Type it in the chat box, but don't send it. And when you're ready, when you have solved the puzzle and ready, when I tell you, send it together in one shot. All right. I usually call it the chat bomb. That is, all of a sudden, when everyone sends it in the chat box, it will be like an explosion happening out of nowhere. So give a shot, solve it, and if you have the solution or the best guess that you have, put it in the chat box, but don't send it yet. When I tell you, send it together. The time starts now. All right, I hope you're trying this puzzle. And if you're done, also think about what was this puzzle? You have studied about it in class. What was it about? Think about it. Your best guess, type it in the chat box, and in a minute, you can send it in. Let's create an explosion, in other words. Not yet, not yet. Don't. Oh my God. All right, time's in. Please send in your answers. Quick. Let's see. Oh, yeah. It exploded. A tiny explosion happened. I'm waiting for others. And please note that all of these are considered for attendance. And in case you are not able to be regular or at time you kept getting logged out, these will be considered as an evidence for you at attending the class, being attentive to the class. All right. Everyone has directly guessed that it's 1. How did you do it? Can someone unmute and mention what did you do to find it? Well, majority seems to have stuck to 1, but how? So I have this theory that teachers are like Dora the Explorer. Can you give some reactions if you know what the series Dora the Explorer is about? Some reaction just to know if you guys are around here. Dora the Explorer? Yeah. So what happens is Dora goes on adventures and Dora will ask, I need to solve this puzzle. For that, what do I need? And then she'll show 3 or 4 options and she'll wait for kids to respond. But the thing is, kids do not know that Dora can't hear what they're saying. So and then Dora will be silent for 2 minutes and then Dora will answer the question themselves. So I always say professors are like Dora the Explorer because they ask, they wait for a minute or two, there's no response, and it's either they can't hear or nobody is saying. I don't know. I think you guys are trying to say because you guys seem to be a wonderful class. And then I would answer the question myself. All right. Can someone help me out? Tell me what made you choose 1? What made you choose 1? Okay, 2 minutes of silence is over. I'll take over. 7 minus 2, 5 minus 2, and 3 minus 2. Similarly here, 9 minus 1, 8 minus 1, 7 minus 1, 11 to 8 is minus 3, and 8 to 5 is minus 3, and 5 to 2 is minus 3. Going ahead, 13 to 9 is minus 4. I can't, yeah, someone unmuted. Yes. And 9 to 5 is, yeah, minus 4. And 4, 5 to the next number should be minus 4. That is 1. Well, you may be wondering why I'm doing these puzzles instead of talking about wealth management. So I'm going to, I need to save time to talk about wealth management, right? I'm going to give you 30 seconds. Quick. Find the next number. Keep it ready in your chat box. Don't send it yet. When I tell you, quickly send it in. All right. Don't send it in yet. When I tell you, quickly send it in. Guess the next number. Get it ready. Send it in. When I tell you. Not now. Wait. 5, 4, 3, 2, 1. Right now. Send it in. I see a lot of 9s, but okay, 9 is one possible number. And what if I say next number is 11? What if I say next number is 11? Yeah, someone said I have a company here. Someone said 11. So the thing is, we have multiple choices for us. Either we can consider it as adding 2, or we can consider it as adding 2 each, 3 plus 2 and 5 plus 2 and 7 plus 2, and that will be 9. But you can consider it as consecutive prime numbers, 3, 5, 7, and the next prime number is 11. What I'm saying is these puzzles are very interesting, but at the same time, there are chances that there will be confusion. And that's where, as I told you, maths is a language with which we write things precisely. That's where we name some type of sequences saying this shows a pattern. This is the kind of pattern it follows. Remember, recollect them if you can, but get ready with the answer. I'm going to give you 15 seconds for this. 1, 4, 7, 10. What's the next number? And 15 seconds. Type the answer in the chat box. Don't send it in yet. Don't send it in yet. And 5, 4, 3, 2, 1, go. Send. Right. The class is in unison when it comes to 13. Unity when it comes to 13. All right. Everyone seems to be voting for 13. So next question. All set? 2, 4, 8. What could be next? Get your answer ready in the chat box. Don't send it in yet. The reason I'm sending the question just before sending it in is because it makes as a future when you're reading through the chat, it makes sense. What did we type? Okay, what could be next? And 5, 4, 3, 2, 1, send. Everyone seems to be agreeing on 16. Interesting. All right. There is an agreement on that. Next question. 2, 6, 18. And you have to find the next number. What could it be? Get ready with your best guess in the chat box. And I'll tell you when you can send it in. All right. 5, 4, 3, 2, 1, go. Send it in. Well, 54. How did you reach 54? Can someone unmute and mention? How did you reach 54 as the answer? Everyone is confident about 54. Interesting. How did you reach 54?
Into 3, sir.
Into 3. 2, 6 into 3. Sorry, 2 into 3. And the next one is 2 into 3 into 3. So into 3 square. So the next one should be 2 into 3 cube. So that would lead us to 2 into 27. That is 54. Well, that was also simple, right? All right. Start. Quickly type the answer, and I'll tell you when to send it in. Just jogging your memory in the afternoon. 5, 4, 3, 2, 1. Send it in. Quick. What's the next number? Everyone is so confident about this one. 440. And the logic is very simple, right? N into 110. Of all these, I want you to recollect one term. Do you remember something called a geometric progression? If you remember geometric progression, can you give some kind of reaction? Any of the reactions. If it's a very scary memory for you, you can give, if it's a happy memory, smiling. If it's a scary memory, you can give the surprised emoji. Or if you love it in and out, the heart. Or if you feel that geometric progression is something to be appreciated, clap. But some reaction, would love it. All right. Yeah, some are taking the neutral route of thumbs up. No love, no hate. All right. Now, which among the questions we did were geometric progression? We did a lot of questions, right? Which among them was geometric progression? Can you mention? Either in the chat box, you can tag that chat and reply, or you can type that question in. Which of the progressions we did was geometric progression? 2, 6, 18. 2, 6, 18, etc. So in this question, what happened is you have your initial term as 2, and in each of them, what you're doing is you're multiplying a common ratio, that is common number R ratio, and in this case, it was 3. And therefore, any nth term can be given by A into R to the power n. So fourth term is what we look for, is equal to, oh wait, n, in this case, we started with n minus 1 because we started with 2. So fourth term is A is 2, 2 into 3 to the power 3, that is 54. Now, identifying these patterns is what mathematicians like to do a lot. We look at patterns, try to identify patterns, so that later it may come into application at some point. Keep this in mind, a geometric progression is if A is the first term and ratio is R, a GP is given by A, AR, AR square, etc. So what do we mean by common ratio? Here what we mean is take any term and its consecutive next term. For example, AR by A is equal to R, or AR to the power n by the previous term will be AR to the power n minus 1 will be equal to, we have A going off, R to the power n and R to the power n minus 1 going off R. So that is, take ratio of any consecutive term, you have R itself. I'm just going to tell you this, and I am going to change my topic because, of course, by now you should have this question in your mind. Why discuss about it in length in a wealth management class? Let's get to that. This is the situation. Someone decided to invest a recurring deposit of rupees 40,000 now and a further rupees 40,000 each year for 3 more years. Question: how much would the total investment be worth after 4 years if the interest earned is at the rate of 10% per annum? I'll give you 2 minutes head start to try to calculate this. Go ahead, give a shot and bring out your thoughts. So I'll post this question in the chat box because later if you're referring to these chats, you can actually guess what you were trying to do at that time. All right. Let's see. I'll start the discussion. If you're trying by yourself, you can continue trying. Now, I will make the pen a little smaller. And if anyone has any favorite colors, do mention. I can switch. My personal favorite is this one. Can you see why is it my personal favorite? Okay. But class, so let's use a very serious color, black. All right. Now, this is what we are going to do. We are going to invest. So let's first draw a timeline, because when you're talking about a long-term investment, we have to talk about timeline now. And in 4 years, we are going to end. First year, and then second year, third year, and fourth year. Now, at year 0, we are going to deposit rupees 40,000. After 4 years, at 10% per annum interest, at 10% per annum, how much will this 40,000 become? This 40,000 will become 40,000 into 1 plus, now tenure is 4 years, into 10 percentage per annum. That is 0. Or yeah, let's put 10 by 100, 10%. Can you calculate and tell me what this amount will be? Oh, wait, I made a small. We are talking about interest per annum, right? So we should be talking about. We should be talking about compound interest. I'm sorry. Yeah. So it will be 1 plus, what was the formula? R by N to the power NT. Here, in this case, P. So in this case, it will be equal to 40,000 into 1 plus R is 10%, 0.1 by N is, now it is calculated per annum. So once a year, 1 to the power 1 into 4. Can you calculate this and tell me the amount? It will be 40,000. Oh, wait, I missed a 0 for 40,000. 40,000 into 1.1 to the power 4. Can you tell me what this amount will be? Can you calculate and tell me this amount? ₹58,564 rupees. 58,564. Well, now what do? That is the first year's calculation. After 1 year, we put another 40,000 in. After 1 year, we put another rupees 40,000. Now, at 10%, what amount are we left with? We're left with 40,000. Now we are depositing it for the entirety of 3 years, 4 years, right? After 1 year, we are adding another 40%. That means this amount will collect the interest for remaining 3 years. You have 40,000 into 1 plus 0.1 to the power 3. That is equal to rupees. What will be the amount? Can you put it in the chat box? Calculate and put it in the chat box. Rupees. Will be equal to rupees. Calculate and tell me the amount. 53 to 40. 53 to 40. All right. So again, after one more year, we are going to put in another 40,000. So at 10%, what do we have? 40,000 into 1 plus 0.1 to the power 2. This is equal to rupees. What will be the amount? 48,400. Again, coming down after 1 year, we are again putting in rupees 40,000. So at 10%, we'll have 40,000 which is invested at the rate of 10%. That 10% means 10 by 100 for 1 year. This will be equal to rupees. What will be this amount? 44,000. Why do you not need a calculator for this? Check out the number 40,000 into 1 and 40,000 into 1 by 10. That is, remove 1 0, you have 4,000. So 40,000 plus 4,000 is the final amount here in this case. So you don't need a calculator to calculate this. You can do it mentally. Now, therefore, our total return, can you find the total return? Therefore, total amount total return is the total return will be, can you add it up, because for the initial amount it has become 58,564. Second installment has become 53 to 40. Third installment has become 48,400 and fourth installment has become 44,000, and it adds up to 2,04,204. Well, what was our investment? Investment was 1,60,000 and return is 2,04,204. This is something interesting that you have to notice, because recently an LIC agent came to me and said, we give same plan where you deposit this much amount every year and we give you after 20 years, we give you a retirement benefit which is like way ahead of the present salary. So I was wondering how it is. Now it makes sense. This is how they calculate. And if I deposit this much money every year, even though that's a small percentage of my salary, at this percentage, it rises up to a really good amount by the time of retirement. Therefore, I'll have a good saving by then. So think about it. Retirement plans are something that you have to think about yourself now, mainly because at present, the pension scheme by the government is much weaker and they are thinking of privatizing it entirely. So therefore, you will have to choose the right pension scheme for you for future. And there are many options available in those cases or in recurring deposits. Recurring deposits are a very nice way to save money because you pledge a small amount every month. You don't pledge a huge amount together. Pledge a small amount every month and you'll keep getting interest for money as you add it. You don't have to worry about depositing it because the banks will take care of it by themselves usually. So RDs are a good way to save money for future. All right, now, so take a look at the entire question, how we went through it. The question statement said a person invested 40,000 now and further 40,000 each year for 3 more years. So we were going to do the total investment worth after 4 years. For the first investment, we had 40,000 at 10% per annum. Second investment, we had 40,000 at 10% again. So 40,000 into 1.1 to the power 3. Third investment, we had 40,000 at 1.1 to the power 2. And finally, 40,000 into 1.1 to the power 1. Let me write this. So to get this 2 lakh 4,204, what we did is we added 58,564 plus 53,240 plus 48,400 plus 44,000. This is equal to this 58,564. How did you get? You had 40,000 into 1.1 to the power 4 plus 40,000 into 1.1 to the power 3 plus 40,000 into 1.1 to the power 2 plus 40,000 into 1.1. Does this look familiar to you? Have you come across this somewhere? Have you come across this somewhere, this idea of addition? Or let me further write it. It is 40,000 is common here. So 1.1 to the power 4 plus 1.1 to the power 3 plus 1.1 to the power 2 plus 1.1 to the power 1. Any thoughts? Where did you come across it? Or what could it be? These numbers separately, whatever you have added, what is it? Whatever we added, these numbers separately, what would it form? Any guesses? See how if you divide 40,000 into 1.1 to the power 4 by the next number, 40,000 into 1.1 to the power 3. Cut, cut, cut this, you're left with 1.1. And the next terms also similarly give you the ratio of 1.1. Such sequences were called geometric progression. And in fact, things become much easier. Why? Because turns out if A is the first term, R is the common ratio, and N is the number of terms, then sum of N terms, A into R to the power N minus 1 by R minus 1. Wait, This has a clear-cut advantage here in our case. What is the advantage? Make a note of this formula because this is going to be useful for us. All right. The final value of final value S of an investment to which equal annual amounts will be added is found using S is equal to A into R to the power n. Okay, let's add annual amount A will be added is found using R to the power n minus 1 by R minus 1, where R is the rate of interest. Let's try. We will not believe in anything until we have got our hands on it. Let's try it for the previous question. Initial amount A was equal to 40,000. And every year annually, we kept depositing 40,000 rupees. Now, you may think that 40,000 is a big money, but to save 40,000 a year is not too bad. No, because divided by 12. When you divide 40,000 by 12, what do you get? Divide 40,000 by 12. What is the monthly amount you'll have to save? That's around just 3,000 rupees, 3,333 rupees. All right. So it's not a huge amount, way huge amount. For an average job, that's some amount you can save every year. All right. So at A is equal to 40,000, R is equal to 10%, which is equal to 0.10. We will have final value for our deposit as 40,000 into R to the power n is 0.1 to the power 4. Here n is equal to 4 minus 1 divided by 0.1 minus 1. Can you tell me what will be the, oh, sorry. Oh, no. In this case, it is 1.1. Oh, yeah. Wait. R shouldn't be the rate of interest. R should be rate of interest plus 1 because of our formula from the. So you'll have 1.1 to the power 4 minus 1 divided by 1.1 minus 1. Can you tell me what will be the answer? Calculate this and tell me what will be the answer. What will be the answer for this after this calculation? $4.618. Something is off there then. Let me try then. Something is off. Something is off. Oh, yes. My formula was wrong. R to the power n. This formula was wrong. One second. Let me see. The formula I mentioned was wrong. Initial amount A will be A into R because geometric progression is given by AR, AR square, etc. Right? We are skipping this A term because if you notice here, the last one is into 1.1. So we should rather be saying 40,000 into 1.1 into 1.1 to the power 3 plus etc. No, even that won't work. Once again, let me get my head around this. This is adding up to 18,556.40, is it? Okay, let's try writing the terms down. This is equal to 40,000 into 1.1 to the power 4 plus 40,000, or yeah, let's write it in common. 40,000 into 1.1 to the power 4 plus etc. plus 1.1, which is, in this series, the first term is, so this is equal to 40,000 into series with first term is equal to 1.1 to the power 4, and common ratio is 1.1. Sorry, first term is the other way around here. 1.1 into 40,000. Yeah. Final value will be 40,000 into 1.1 plus 40,000 into 1.1 square plus etc. plus 40,000 into 1.1 to the power 4. So first term here is 40,000 into 1.1, and common ratio is 1.1. N is equal to number of terms here is 4. Now this makes sense. So therefore, final value can be calculated as 40,000 into 1.1, which is our first term, A, into R to the power n 1.1 to the power 4 minus 1 divided by R minus 1. Can you calculate this? Can you calculate this? This makes sense because earlier I tried to generalize a formula that didn't work, but this should work because here first term of 40,000 is missing. We are starting with 40,000 into 1.1. That's our first term. I earlier took 40,000 as the first term. That won't work. So here 40,000 into 1.1 is the first term. And if you notice this addition, we are going to get R as 1.1, ratio as 1.1, N as 4. So can you calculate this and send? This will be equal to, yeah, 204, 204, 2 lakh, 4,204, which is the same as our other calculation answer we got with other calculation. So yeah, what I wanted to point out here is the reason I spent time on geometric progression and then came here is because two things. One, math has found a lot of patterns which are commonly available. And when you are doing some problem which may not be related to math, if you know these already recognized patterns, you can identify them. You can identify that this pattern, this is the same pattern which is repeating here, which will help you simplify the calculation we did here, like the one we did here. So that's why in schools you learn quite a lot of basic mathematics, so that whichever field you study in, like geometric progression, whichever field you study in, maybe using that common mathematics you learn there, you can simplify your calculation. Now, one thing to notice, this was only for 4 years. I told you a LIC plan, right? That plan was for 20 years. So how would you write down these separately and calculate it by hand? That will be hard, right? But here, using math, you can find a quick formula which can solve it for you. All right. So with that small note, I'll wind up for now. And we'll do 1 or 2 more problems of this sort in the next class. Sorry for the confusion in calculation. Anyway, thankfully, we were able to catch it quickly and fix it. All right. If you learn something new, which is related to the subject, what I pointed out is how recurring deposit returns can be calculated, or if you learn something new when it comes to your anything else like mathematics, how can we use mathematics? Give a reaction and you can move from the meeting. I have made a note of the attendance. If you had any trouble connecting or anything, you can always mention it to me. All right, class recordings are available in the same